Hello and welcome to another video on integration techniques. So today we're going to talk about this integral. So it's the integral of the expression x plus 2 that multiplies the square root of 3x plus 2 dx. Now the idea is that we're going to use a substitution. So usually what the choice for the substitution will be, or the variable u will be something which is inside some square root, the argument of a function. So in this particular case, we can use the 3x plus 2 as our choice for the substitution. So we're gonna say, we're gonna call u equal to 3x plus 2. So now remember, after that, what we need to do is we need to find the derivative of that, so which is du. So du will be 3dx, and the reason for that is because the derivative of 3x is 3 and the derivative of 2 is 0 because it's a constant. Now, as you can see there, the 3x does not appear exactly inside the integral. And as we did before, we can actually fix that because we are just off by a constant. So what we can do is we can solve the x in du or divide by 3 on both sides. So if you do that, you're gonna get that the dx is equal to the du divided by 3, which is just division by 3 on both sides of the equation. Du equals to 3dx. So now we know what dx is. So far in the integral, as you can see there, we have that the 3x plus 2 is just the variable u, and the dx is just du divided by 3. Now we still have to solve the problem of having x plus 2 there, because when you do the substitution, everything has to be in terms of the variable u. So now let's look at that. So we need to still know what that x plus 2 is in terms of the variable u in this particular case. Now let's recall something. So the first thing we have to recall is that the substitution is u equals to 3x plus 2. Now we can express the variable x in terms of the variable u from that particular equation, from u equals to 3x plus 2. And what you can do there is solve for x. So we're gonna solve for x there, and we're gonna obtain that x is u minus 2 divided by 3. Now how did I get that? What you do is, from the equation u equals to 3x plus 2, you first subtract 2 and then divide by 3. That's how you get the expression x equals to u minus 2 divided by 3. So now that we have done that, we can express the whole integral in terms of the variable u. So as you can see there, so x plus 2, the x is the only thing I have to replace by u, which is u minus 2 divided by 3. The square root of 3x plus 2 is u, and the dx is just du divided by 2. So with that information in mind, just what I just said before, now we can make the substitution. So now we can make the substitution there and see now the new integral in terms of the variable u. So the new integral will be that u minus 2 divided by 3, because that was x, plus 2, that was the constant that was there, and square root of u, because u is 3x plus 2, and the dx, of course, is du divided by 3. So this is our new integral. Now this integral should be easier than the previous one. So that's the purpose of the substitution, is to make things easier for us to integrate. So one thing we can do actually is take the expression that is u minus 2 divided by 3 plus 2 and simplify a little bit. So what I did there is basically just I took the number 2, the plus 2, and the plus 2 became 6 divided by 3, which is just multiplied by 3 on top and bottom. And the reason I did that is because I want to have a common denominator to add the two expressions that you see there. So I have that, and then I'm gonna add them. And so because they have the same denominator, all is divided by 3, and u minus 2 plus 6 is of course u plus 4. So I have this new integral, which you will see in a second that will be easy to integrate because it's gonna be just expressed in terms of powers of the variable u. So now we can look at this integral. That's the one we have so far, which is u plus 4 divided by 3, the square root of u du over 3. Now let's get rid of some constants there to make things easier. So you see the 2 3's at the bottom, they will multiply and they will give me 1 9, and I can take that expression or that constant out of the integral, and I can do that because that's a property of integration. So inside my integral, I just have u plus 4 times the square root of u du. And you see in a second why that is just all powers of u, because if you can see what I just did there, I made that square root of u as u to the 1/2. That's just properties of exponents. The square root of u is the same as u to the 1/2. With that in mind, I can actually now express everything in terms of powers. So this is the integral we have so far. I'm going to distribute the u to the 1/2 to the parentheses u plus 4. So if I do that, I get this integral, which is 1/9 u times u to the 1/2 plus 4 times u to the 1/2. That is because I distribute the u to the 1/2. And now with that, I can apply the rules of exponents, and u times u to the 1/2 is u to the 3/2. The reason for that is because I added the exponents 1 plus 1/2 in that multiplication. So I get u to the 1/3 plus 4 u to the 1/2. Now, that expression that I have there is just an addition of powers of u, which can be integrated easily using the rule for integration for powers. So I can distribute my integral. So it will be the integral of u to the 3/2 du plus the integral of e to the 1/2 du. And now with those two things that I have there, I can just apply directly the rule for powers, which is, remember, 1 over 1 plus n, u to the 1 plus n. And now that's exactly the rule I'm applying in both cases. For both integrals there, I'm applying the rule for integration. And don't forget to add the plus c there. Now, this particular example I'm doing a lot of detail. You don't have to do that. You can skip some steps if you actually see them that fast. So I'm just going into the details of all of that. Now, so far, actually, we are done with the integral because I already applied the rule. So I just need to simplify a little bit more. So what I simplify here is 1 over 1 plus 3/2. That becomes 2/5, as you can see there. And 1 over 1 plus 1/2 becomes 2/3. And the same happens with the exponents. 1 plus 3/2 becomes 5 over 2, and 1 plus 1/2 becomes 3/2. So now it's a really simple expression of powers of u. So that's what we have so far. So the integral is already solved, but let's simplify this a little bit more. So I'm going to distribute that 1/9 that you see over there, and so I get 2 over 45 u to the 5/2 plus, and I multiply the 4 and the 2/3 times the 1/9, and I get 8 over 27 u to the 3/2 plus c. So that's just the constant of integration that I have at the end. Now we have to replace back the u, because remember the integral was in terms of the variable x. So I'm going to replace back the u in this case. So the u is 3x plus 2, so I just replace it in my expression, the expression I already got from before. So this is what I get, like this expression that you see over there, by doing the replacement of u. So this is what I have now. So I can actually turn those expressions into radicals, as you can see there, because every time you have an expression to a fraction, the denominator of that will be the kind of root that we have. So in this case, we have a square root. Now, in this case, this actually will be done. This will be the answer for our problem. But I want to go a little bit further here because I'm giving a lot of details. So let's just complete the whole thing. And what I want to do is simplify algebraically this a little bit more. So I'm going to take that expression that you see there, and I'm going to simplify that. So as you can see, those two terms that I have there, I have a common factor of 2/9, that 3x plus 2 to the 3/2. So they have that common factor. So the idea is that I'm going to factor that out. So if I factor that out, the common factor, I get inside the parentheses 1/5 of 3x plus 2 plus 4/3. And you can double check that just by multiplying back or distribute that common factor inside that parenthesis. So I have that expression now, and there's a little bit of algebra that I have to do now. Inside that parenthesis, I can do the common denominator. The common denominator will be 15. So for the first fraction, 1/5, I have to multiply by 3 top and bottom. And for the second fraction, 4/3, I'm going to multiply by 5. And so that's what the fractions that you see there now. So everything now is in common denominator 15. So I can just go ahead and put all under one common denominator. So I have the fraction 3 that multiplies 3x plus 2 plus 20, all divided by 15. And I can simplify the top of that fraction there. So multiply, distribute that 3, and then add 20. So I get 9x plus 27, all divided by 15. And we are almost pretty much done. The only thing I'm going to do is a little bit more algebra here. I'm going to multiply the 9 and the 15, the denominators, to get 135. So I have this expression now. And there's a little bit more thing I want to do just to make it pretty, just like that. So this will be actually the answer. So now I'm going to put the linear factor first, which is 9x plus 27 plus 26, and then the rest of the expression. Now I'm going to turn that 3x plus 2 to the 3 halves. I'm going to turn it into a radical now. So it's going to be a square root. So the final answer will be the expression that you have there. Now I have done a lot of detail on this integral. So this is a little bit more difficult than the ones we solved before. It has a lot of algebra. I gave a lot of detail. But again, when you're doing your computation, you can skip some of the algebraic steps that are very simple here. So this is the example for this video. So in the next video, we'll actually start with the other integration technique that will be integration by parts. Thanks for watching, and I will see you in the next video.